In this video, we are going to discuss about a new form of threads introduced in C++ 20 standards called Jthread. Now, why we need another form of thread? Well, there are a couple of reasons. First, with current thread, we have to explicitly call join or detach on threads we launch. Otherwise, when the thread's destructor get call, std terminate will be called, and this is an undesired behavior. To address this, we previously introduced joiner class, and we extensively used that joiner class throughout this course. But it is really convenient if we have a thread which itself manage its life cycle and no need for explicit mechanisms like joiners. The second downside with current thread is that after we launch our thread, there's no way or no standard mechanism to interrupt its execution. Of course, we can use a Boolean reference or any other inter-thread communication mechanism to handle these issues separately, but it is so convenient if it is built into the standards. In original C++ technical specification draft, initially, it had to interrupt API in the thread class, but for a variety of reasons, when it finally standardized interrupt function hasn't made to the standards, but in boost thread class, it has this interrupt function, and considerable amount of developers still use boost threads instead of a standard thread solely due to this interrupt functionality. All in all, the ability to be able to interrupt the running thread is powerful and useful functionality. So with Jthread, we are going to have that facility as well. So here's what I'm going to do. I will first describe to you how to use Jthread, and then we will try to build our own version of Jthread, like interruptible thread, to understand the concepts. Like almost all C++ 20 standard specification, MSVC compiler does not support Jthread, but GCC 10 onwards compilers do support Jthreads, so we have to use newest version of GCC compiler to use these functions. So let me open Compiler Explorer and show you how to do this. Okay, this is my Compiler Explorer window, and I'm going to select GCC 10.2 as the compiler. Also, we have to set the compiler option to use a C++ 20 standard, so we can specify it with the std option in this way. Also, Unix system does not usually linked to pthread libraries implicitly, so we have to specify to link pthread using -pthread compiler option. Now let me define a simple function. Let's say do some work function here. This function is simply print out a string to the console, and that's all. Now in the main thread, I'm going to launch a thread to execute the above function. Now if you look at output window, you can see there's a familiar runtime error, as we saw in the first section in this course. This error happens as we have not called either join or detach on threads that we just launched. So if we simply call joined on the thread, error went away, and in this case it printed out do some work to the console as we expected. Now let me use Jthread instead of standard thread. So now you can see there's no error in output window, even though we don't have any join call. This is because Jthread manage its life cycle implicitly. So there's no need for us to call a join or detach explicitly, as when Jthread's destructor gets called, the thread will call join function on itself, if the thread is joinable at this stage. Notice if you want to detach thread, you have to perform that action explicitly. Jthreads do two things in destruction. First, it will try to interrupt the work it's being carried on, which we will see in a minute. Then call join function. Okay, that's it for automatic threads lifecycle management with Jthread. Now let's move on to interruptible aspect of Jthread. To achieve interruptibility, Jthread is working with another construct called stop token, we can introduce condition checks using this stop token inside the tasks, and these are the points where we can interrupt the thread's execution. Let me explain with an example. So here, let me have a function call doSomething, and this function will take stop token as an argument. This function has a counter, and it will run until this counter reaches value 10 while printing out "this is an interruptible thread" to the console in this way. To have a demonstrable output, I'm going to have 0.2 seconds of sleep in each iteration. Now we can introduce an interrupt point to this code. We can simply check whether the stop request is true for this token here. Once this thread is interrupted, the stop request will return true, and then you can simply return from this thread. Notice in this function, the stop token is the only parameter, but if you have a function with parameter list, you can have stop token as the last parameter. Then you will be fine. Okay, let me copy this function and paste it here, and remove the stop token from argument list and remove that stop request condition check as well. Let's rename this function to doSomethingElse. Now from the main thread, I'm going to launch two Jthreads, one with the first function we wrote with the stop token, and the letter function which does not have stop token. Then, let's put main thread to sleep for 1 second, then call interrupt on both these threads. Okay, let's check the output now. As you can see here, interruptible thread ran only a few iterations 0 to 4, and then it have not output any strings to the console, which indicates in fact the thread has been interrupted. On the other hand, other thread keep ran until it's complete the iteration in the loop. Notice we have not provided any argument to our threads, but in the first function we have stop token. This stop token tells compiler that there can be interruptible points in the function. That's all. No need to provide any argument. When thread.interrupt get called, this stop token will notify that there is a request to stop the thread, so that in interruptible point where we use this stop token, we can interrupt the execution. For the second thread, there's no interruption point, and we have not provided any stop token there, so even though we call interrupt on the second thread, it's still run until it's finished the execution because there's no interruptible point. So that's how we can use Jthread to interrupt the execution of the thread. Okay. Now we have seen the basic usage of Jthread. In the following videos, we are going to implement our own version of Jthread.